Use computer. All right. So last time at the beginning, we were talking about how Bittorrent works, and we talked about there still being a client server model. So our current setup looks like this, where we have a server in the middle and we have a sender and we have a receiver, and the server hands off the bits between these two. So all data is actually moving through this central server. So it becomes a bandwidth issue that Bittorrent is trying to solve, not necessarily removing the entire server. So a lot of times when somebody, when somebody asks what's Bittorrent, the natural response is, oh, it's a peer-to-peer network, which is mostly true, but it still involves a server. I think I mentioned last time that server is called a tracker, I think typically, yeah. Central server is called a tracker, and effectively the job of a tracker in Bittorrent, its job is to hold the IP addresses of all participating now let's just call it clients for a particular torrent. Okay. We're only going to have a single torrent in our example, but so this tracker is going to hold a list of the, let's say there's 100 computers all participating. It'll have the IP address of all of those computers, and we're going to try to answer a question here in a few minutes. I asked that you kind of think about it for today. So this is the model that Bittorrent would use. They're not showing the tracker here, but somewhere there's going to be this tracker that all these guys had to reach out to find out about each other. Okay, so now I want to draw a picture. I was mentioning something about firewalls and things like that last time. So let's draw a picture of what this guy actually looks like. So we'll throw our tracker up here. We're going to say the tracker is sort of kind of the easy part for the first part of this discussion. All right. Then we're going to have our clients. And we're going to build this in what's likely to be like reality. In class, we've been doing this where we're, all sitting on the same network, but chances are in reality, every one of these clients is sitting behind a router on the internet. So here we'll just say that there's 3 people participating in this. So all 3 of these computers have opened up a communication channel to the tracker. There's going to be an important thing dealing with network programming here. All right, so all of these have opened a door going out, away from their computer to this tracker. All right, and even if we assume that this tracker is sitting behind a router somewhere, which it probably is. A lot of times a router is the actual name of the network equipment, but this guy's really operating as a firewall. It's blocking access to certain incoming ports. So let's assume that this tracker is listening. In fact, here we can even look it up. Bittorrent tracker port. $68.81 is what it looks like. So we're going to say something. Oops. I say 68.81. So this router has opened up port 6881. Just want to confirm that's what it was. 6881. It's 6881 TCP instead of UDP. UDP is a data packet port. TCP protects to make sure the data receives without error, which is obviously what we want here. So 6881 port is open in this router to allow those connections to that port to come through the router to our tracker. So the network people over here, the IT folks, they would have to configure this router to allow incoming connections asking to go to this port to get in. Okay. Now this tracker, let's just go ahead and paint our picture here. Green, so let's say that this is 143.21.237.3. All right, so that's the IP address of this router. This is the IP address of this router. So let's just change this to like a 173 and 217. So we'll keep it close-ish so I don't have to change too much. And then this one is 202. For a 27 and an 8, something like that. All right, so these are the actual routable IP addresses on the internet for these routers. So these are real IP addresses that are accessible somewhere on the internet. And this router up here is also going to have an IP address. Close enough. Right. So this computer, we're calling it a tracker. This is guy's acting as a server. He's going to hold on to this IP address, or he's going to have this IP address. So all of these connected clients running something like Bittorrent or whatever torrent application you use, they're going to open up a connection to port 6881 on this at this IP address, which is going to let you into the tracker software. And what is the tracker software going to hand out? Well, it's going to have some pieces of information in there. So for instance, it's going to have the 202.4.27.8. It's going to have the 173.21.217.3. And it's going to have the 143.21.237.3. So this is the information that tracker knows about. These are the client computers that are participating in this particular sharing of bits. And just to close the loop on this a little bit. Change the color of this a little bit. All right, so what I have written in blue here, so this is 3 different people's houses, let's say. So they have their own, cable modem / Wi-Fi router, whatever it is. Those things have actual IP addresses on the internet. That's potentially possible. They might also have fake IP addresses like this, and the router at the internet service provider actually does the mapping. But this is also a realistic model. So let's just look at it like this. So our cable modem has a real IP address that uniquely identifies us on the internet, but then inside our house with our, 3 different smartphones and our 2 computers and our couple of TV sets and our Xbox, whatever it is, our internal router is handing out fake IP addresses to our inside computers. These are non-routable IP addresses, meaning they are not unique across the entire internet. In fact, in my example here, I have 2 of these different computers just happen to have the same local IP address, 192.168.2.2. Right, so that means that this person's router handed out this IP address to their computer, and this other person's router happened to hand out the same IP address to the computer that's in their house. So these computers are unique. These IP addresses are unique inside the network inside this house, but not unique across the entire internet. All right. And then I gave you another example of a non-routable IP address, the ones that start with a 10. So 192.168 are things, and then 10 dot things. All right, so in any case, here's the real IP address, these guys, to uniquely identify them on the internet that I have in green. The blue is how they're referenced inside of their inside your house. And the important piece there is, for example, if I go up to my Wi-Fi up here, my IP address right now is 192.168.1.136. That is not something that any of you will be able to directly connect to. That's a non-routable IP address. My computer is only unique inside of my house right now. Whereas my router itself might have a real IP address like one of these. So some of you might be able to try to connect to my router, but unless my router has a door open, similar to like the 6881 port that we opened up here, you wouldn't be able to get to any of these internal software applications. Similarly, when we connect to Concordia, Concordia has port 80 open. So www.cuw.edu takes us to one of Concordia's computers. Well, actually, it's probably taking us to Concordia's router, which then has port 80 open, which redirects us to some internal IP address that is the web server at Concordia and is serving up web stuff on port 80. All right, so all of these connected clients, they're going to reach out to this tracker and say, who's currently playing the game of whatever torrent we are downloading here. So some image or something like that we were sharing before. All right, so these are the 3 computers that are all participating. So these 3 computers have some percentage, potentially the entire file. So I think we mentioned before with BitTorrent we have leechers and seeders. So people who are seeding values. Well, everybody who's on the BitTorrent network is going to be seeding and leaching at the same time initially. But once like this computer has all of the data for the file, they would then just be a source for that data for the rest of the network where people can download bits from them. Because they've already retrieved the value, retrieved the image or whatever they were trying to download. All right, but we're going to assume that all of these are good Samaritans and are not going to do the what a lot of folks do with BitTorrent, where as soon as they have downloaded the file they want, they immediately disconnect, and they're not going to help the network anymore. They're just going to, what's in it for them, and then get out of there. But they're all going to stay connected. So each one of these guys, they open up a connection to the tracker. They find out who's participating. If we go back to our picture in here, that allows them to find out about each other. Okay. So now all of these client computers, they now know about each other, and they know about the IP address of those machines. And notice that in my picture here, these are the real IP addresses of these internet connections, not their internal IP addresses. All right, so once they have that, in this picture, you see these guys are going to start talking to each other. All right, because presumably at any point in time, let's draw the picture. Let's see, how do I want to represent this? So we're going to say this guy has is that 8 of them? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that works. All right, so at any point in time, what I have in this little magenta box, we're going to assume that the file we're sharing is only 8 bits big, just for the sake of our visual here. All right, so these are our 8 bits of our file. So this particular client, he does, anywhere there's a 0 is a bit he does not have. So he does not have the bit at bucket 0, 1, 2, 3. He does have the one at 4, not 5 or 6, but he does have 7. Similar here, this guy has the one at 0 and 1, but not at 2 and 3. He has it at 4 and 5, but not at 6, but he does have it at 7, so on and so forth. All right, so each of these computers that are participating in this network at this point in time, in our little snapshot that we're looking at here, have a portion of the file that they're all trying to share with each other. All right, now in the ideal world, these guys would share those bits with each other. They're because what we're trying to avoid here is we don't want this computer to get bits from this computer by way of this tracker. We don't want the bits to flow up to the tracker and then flow back down into this client, because then we're no better than what we currently have. What we currently have in our file sharing is this picture, where all the connected, this guy's a sender, this guy's a receiver, and all the bits flow through the server, which means that this guy's using up a whole bunch of his bandwidth. That's the problem that BitTorrent is solving, is minimizing the total amount of bandwidth put on any individual computer. All right. So in this particular case, if you had 6 bits to share and all of these computers had some number of those bits, this guy can get some bits from this guy, 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 so on and so forth, so that his burden on the rest of the network was distributed across all the computers that are on the network. Okay. Let's see what that's saying right here. Yeah, so here's like that line. The BitTorrent clients never actually download files from the tracker itself. The tracker participates in the torrent only by keeping track of the clients connected to the swarm. They're calling it a swarm. That's this network of computers, not actually by downloading or uploading data. So that's what we are trying to accomplish here. We're keeping it very minimal of the amount of data that's flowing through this guy. This guy is just there to send and receive small amounts of textual data about the people who are currently participating in the network. Okay, like I mentioned before, we have this idea of leechers and seeders. So people who are downloading from a storm are referred to the leechers. People who, you know, these are also the peers that are participating on the network. You know, so every one of these computers is a peer. Sometimes these are called peer-to-peer networks. This is a peer, this is a peer. So these guys might be sharing files. But if they're in the business currently of downloading something, they're considered a leecher. If they're in the business of somebody uploading a file, then they are seeder. So users that remain connected to a BitTorrent swarm even after they've downloaded the file, the complete file, contributing more of their upload bandwidth so other people can continue to download the file. These are referred to as the seeders. So if you're in upload mode, you're seeding the file. If you are only seeding a file because you already have the whole thing, well, then you're one of the good Samaritans of BitTorrent who are actually, you know, helping support that network by being a part of a possible location for some of those bits to flow. So if a, you know, so for a torrent to be downloadable, one seeder who has the complete copy of all the files in the torrent must initially join the swarm. So somebody has to have all the files initially. You know, you can't just join a torrent where not all the files are available. Did I cover all the bits here? Doesn't look like we do have, well, here, we'll just, that guy has all the bits. So this was our original seeder. He has all the files. He's seeding the network. All these other guys are starting to collect them somehow. We'll talk about how that works. So those other users can start downloading the data. If a torrent has no seeders, it won't be possible to download. So if nobody is uploading bits, doesn't matter how many people are trying to download bits, you'll never get it. That's why when you've gone to a BitTorrent site, you try to see the number of leechers, number of seeders. If it currently says 0 seeds or like 2 seeds, let's say, and there's 5,000 leechers, or even if, you know, you're one of the only people who wants to leech, if there's only 2 people seeding the file, you're going to be limited to the bandwidth of those 2 people, and you're also going to be limited to whatever bits those people have, because at this point you don't necessarily know what % of the file is shared between those 2 seeders, because nothing requires, because remember they just say he initially needed to join who has all the bits. Nothing requires this guy to stay on that network sharing the bits forever. Once he's initially seeded the swarm, and you know those bits are flowing around, and hopefully between all the other people that are participating in the network, across all of them, the bits are represented. This guy could then drop off because now the bits are out there and obtainable somehow. All right, so part of this is this gets into some of the reward type stuff where you can download faster if you are uploading more. BitTorrent clients reward other clients by uploading. Prefer to send data to clients who contribute more upload bandwidth rather than sending data to clients who upload at a very slow speed. So this speeds up download times for the swarm as a whole and rewards users who contribute more upload bandwidth. Ultimately, what's the problem that BitTorrent is trying to solve? It's trying to distribute the upload bandwidth, the amount of data that's being sent out of a computer across the swarm, across this larger network of peers. All right, so before we go further into this, let's go back here. So we're inventing our own BitTorrent-like situation here. So all these computers, they have some part of the file that wants to be shared. They've connected to the tracker. The tracker has all of their IP addresses. First of all, how does this computer, well, let's ask this question first. If this computer right here wants to get some of the bits he's missing bit number 3, this guy right here. If he wants to get bit number 3, how does he find out who has bit number 3? And we can go ahead.
This isn't necessarily a good solution, but like you could connect to another client and then be like, search through the bits they have, see if they have bit 3, take it, and then keep going if they don't have any of the rest of the bits you're missing.
Okay. So maybe talk. So the question is, and so you went to the direction, I think the good direction, where let's talk to other clients, let's not go bug the tracker about who has the bits, because we want to limit the amount of data the tracker's keeping track of, because we don't want to limit the amount of bandwidth that this tracker needs to be dealing with. So maybe this computer, since he now has a list of everybody who's participating on this, and maybe he refreshes his list, I don't know, once a minute or something like that. You can decide what your cadence is that you refresh the list, or maybe the tracker gets set up to push updated data to, when somebody connects to the tracker, they maintain that connection open. I'm not sure if that's the best idea in the world, but if they do that, then the tracker would be able to, if a new client connected, they can then push that IP address down to those that the other connected clients, saying, hey, there's a new guy in town that you can possibly bug for some of the bits that you need. All right, but one way or another, these 3 guys now are all aware of the participating clients. So they know about the IP address of those other clients. They'll find that they are also on that list somewhere. But so now all these guys, they got what they needed from the tracker. So we can even assume, for the sake of this argument, that the tracker is no longer even in play. That these 3 clients are sitting there and they know about each other. So Emily suggested, well, maybe this guy, he goes and talks to one of the other clients, somebody who's on his list. Maybe he just kind of, dials up a phone number and says, hey, do you have bit number 3? I need bit 3. Do you have it? So if they do, they send them bit number 3. Maybe we're not doing it on a bit by bit basis. Maybe they're sending a little bit, because at some point, if the amount of back and forth talk you have to have takes up more data than the data you actually need, you're maybe not operating very efficiently. So maybe you're getting a byte at a time, you're getting 4 bytes at a time, whatever it is. I'm not sure what the official BitTorrent protocol actually, what their optimization ends up being, but at the end, we're going to deal with it on the per bit basis, because it's going to show us the our algorithm here. Although when we write it, it would be on probably the per byte basis, because that's how we know how to read and write stuff, is by the byte. All right, so this guy's just going to go down his list. He's going to say, okay, first phone number I can call is 202.4.27.8. So he's going to, let's say, call over there somehow. We'll deal with the somehow here in a minute. He's going to call over here somehow and ask this dude, say, hey, do you have bit number 3? This dude's going to bounce back and say, nope, I don't have bit number 3. Sorry. So he's going to hang up the phone. He's going to call the next guy. Next guy is him. So he's not going to do that. He's going to call the next guy who's not him. That's this one here. He's going to call him. Hey, do you have bit number 3? Yes, I do. Okay. So he'll send him bit number 3. This guy then fills in his bit number 3. Now he's looking for bit number 4. Maybe what he does is he goes ahead and since he already has the phone call established, maybe you say, well, do you have bit 4? Yep. Do you have bit 7? Yep. So this guy's going to be able to complete it by kind of talking to this one client and start collecting as many bits as he can from that one client until that client, fails him at some point. Now, nothing says that you actually need to get the bits in the correct order. So each of these could have multiple threads. So maybe we have one thread in charge of filling out the first 4 bits and another thread for filling out the second 4 bits, for example. So this thread's going to make those phone calls, trying to do his job of filling out 4 bits here. Another one's going to make the similar phone calls. Maybe you can put some stuff in there to make sure the 2 threads don't call the same guy, but maybe that's not that important. If they call the same guy randomly, then that's just the way it's going to be. So you get that, hopefully you start collecting your bits until you don't need any more bits, until you filled out everything. And then your threads die off because they've completed doing their job. Maybe you also decide that you're going to randomly call your phone numbers here. So maybe when you get a list of IP addresses, maybe you randomize, kind of like treat it as playing cards. Maybe you shuffle that list of IP addresses. That way, all of these connected clients aren't dealing with the exact same list of phone numbers, list of IP addresses. So they're not always contacting the people in the same order, because ultimately what you want to do is you want to create a scenario where you're spreading those bits across the swarm, across the network of connected peers. Okay. But anyway you cut it, you're going to have this guy's going to make a call. He's going to say, do you have this bit? So these guys are going to negotiate a little bit. There's going to be a protocol that's happening between these 2 connected clients. And that protocol is going to determine whether somebody has a bit you need or doesn't. And then maybe they keep talking as long as he can fulfill the bits that he's looking for. And then he moves on down his list. Okay. I think that's a reasonable enough approach. Whether it's the most optimal approach in the world, who knows? But it's a reasonable way of trying to share the bits. But now we have the issue. When this client tries to make a connection to this client, because now he knows his phone number, he knows his 143.21.237.3. He makes a connection there. How does he reach this computer? So we're referring to this guy as a client, but how does this guy open a connection to this guy so that he can even ask this guy, do you have bit number 3? If you were writing that, how would you set it up so that he's able to open up that connection? So this is nothing new for us. Up to this point, whenever we've had something that's listening, we've called that a server socket, right? So they behave as a server. So anytime that you're going to be a seed, anytime you're going to be in the business of sharing bits, you will act as a server. You might also act as a client, but you're going to also act as a server. So is it possible? Let's see, we can oh, it looks like 6969 was the tracker port. You can let's just assume it's one of these. So it looks like there's a range of port numbers for the seeders to use. But let's just use this first one, 6881. Oh, that's what I actually had up here. Let's actually keep it that way. This probably actually is the original BitTorrent protocol. And, you know, even though this document here talks about, you know, BitTorrent isn't just for piracy type stuff, you know, it certainly kind of started that way. And, you know, maybe the folks who picked port numbers didn't necessarily pick the most mature port numbers. So we'll assume this is the tracker port, and we'll come down here and we'll say that when each of these clients acts as a server, they'll open up 6889 port to seed bits. So they become a server on port 6889, which is going to be very similar to what we've already set up, what we set up with our chat server, what we set up with our current file sharing server, where we're going to sit there, we're going to listen for an incoming connection. So this guy is going to open up an incoming connection to port 6889 and say, hey, do you have bit number 3? Do you have bit number 4? Whatever it is. But he's going to be, this client's going to be establishing a socket connection to this server who's listening on port 6889. Now, in order for him to be listening on 6889, he's going to have to update his router. He'll have to, you know, you've probably seen this before when you've installed software on your computer. It'll say that, you know, this installer is requesting to modify, you know, Windows Defender or Windows Firewall. You know, what it's probably doing is it's probably opening up a port number so that it can communicate with, well, that the cloud or whatever can communicate with it. So if you want to run a server out of your house, you're going to have this port on your computer open. 6889 is going to have to be open. Now you can decide, depending on how you've locked down your house. This is your client computer. So in let's just say on your average scenario, you're sitting on your couch with your laptop. That's your client computer that has this IP address. Your router is your cable modem, let's say, that has this real IP address. Well, normally what you'd probably have is you probably have all requests that this client make go through this router. That's something called a NAT, network address translation. So when this client tries to go to web page www.google.com or something like that, the router actually makes that request on this computer's behalf, and he receives the response, and then he forwards it on to this client. That way the router doesn't have to let external entities directly reach this client. But in this particular case, if this client is having to act as a server, he's going to be a listener, just like we did in class where we had our chat client set up. If this guy wants to listen for external connections, and those external connections live on this side of the router, not inside your local area network, but if they live on the outside of that router, this router is going to have to let that channel through. Sometimes it's called port forwarding, something like that. So you would have to go in and modify your Wi-Fi router. Most of them have software on it that lets you do it, and you would open up port 6889 for you to be able to see bits. The alternative is maybe your cable modem doesn't have any ports blocked, but instead relies on your computer to have firewall software like Windows Defender or whatever to block the ports in software. That's probably the way that it's mostly working today, where the computer itself is locked down, not necessarily the network. But maybe one of the purposes of a commercial router is to block incoming traffic before it ever gets to these internal machines. Okay, but any way you cut it, if this client needs to listen on port 6889, this router is going to have to allow an incoming connection on 6889 to get through to talk to this computer, because you're going to have your little Java program here running with your server socket listening on that port. And this connection is going to hit this router on that port, and the router is going to say, oh, you want to talk to one of my internal clients who's listening to that port. He set up port forwarding. So I'm going to go ahead and you're trying to talk to me on port 6889. I'm going to forward that to this computer on 6889. So whenever you see port forwarding, that's what it's talking about. The router passes on a communication on a port to an internal machine that's actually listening on that. Okay. So that's the way we would actually have to handle it for a true peer-to-peer network. Something else we could do is, whether we use the tracker to do this or we use another server that's sitting out there publicly to do this, is we can sorry, we could have this computer go to ask our tracker saying, I need the communication channel to talk to this guy right here. And he can then connect the dots for them. He can connect the two sockets together. The problem with that, though, is all data, since those two incoming sockets came to this place here, all those bits are still flowing through this tracker. So now we're back to our problem of having our client server model where all the bandwidth is being taken up by a single thing. So we really wouldn't want that. We want these peer-to-peers to be able to talk directly to each other, which is going to require your Bittorrent software you install on your computer to open up a port on your Windows Defender or whatever, so that this guy can talk to him directly. All right, so this guy is going to open up a connection to this IP address on 6889, let's say. And he's going to, since this client potentially is going to be serving other clients other than just this one, it's going to be just like our chat server, where he's going to spawn off a worker bee, and that worker bee is going to actually handle this guy's requests for bits, while this client sits there and waits for another incoming client. Maybe this guy also connects to him because he's hunting for bits as well. So you have two different threads over on this computer, all trying to share bits. You hope that not all 5,000 connected clients are all talking to the same computer for all the bits. That's why you want to kind of randomize the list of IP addresses, the list of phone numbers, so they can start reaching out and talking to those different machines. Okay, but one way or another, they're going to establish a connection and then go through a protocol. It's going to ask, do you have a certain bit? And maybe you ask for a whole bunch of bits at once. Maybe you ask for just a single bit. And if they can't help you, then you bail. Maybe it's a 3 strikes and you're out type policy. It's like, well, do you have bit 3? No. Do you have bit 4? No. Do you have bit 5? No. Okay, take a hike. But as long as they haven't had 3 fails, maybe they'll just keep asking for bits until they feel like they haven't gotten they've gotten as much efficiency out of this particular seeder as they possibly can. Now these clients are going to keep doing this over and over and over again until they filled up the bits they expected to receive, so that they have the entire file. At that point in time, they can choose to reach out to the tracker and take themselves off the list, or they can maybe that's probably the most correct way of doing it, or they can just disconnect, and then they're technically, their IP address is still sitting on this list, but they don't have an open port listening for an incoming connection. So if somebody did try to dial them, they'd get the equivalent of a busy signal, or this number has been disconnected type thing. So they would just move on to the next number to try. All right, so at the high level, that's effectively how the Bittorrent network works. So what we need to do in order to start writing this is we need to write our tracker portion of this guy. And the tracker portion of this guy is going to have our a client can connect and register their IP address with this running computer. And then they get broadcast back all the other IP addresses of the guys that have checked in. Okay, but they don't have to maintain these IP addresses. So if we come back in here, oh, that's here's VS Code, right? All right, how do I have this written right now? All right, well, what we're going to go ahead and do is I'm going to create another file called tracker. Tracker.java. So here's our public class tracker. Okay, so this tracker is going to set up a server socket. Let's see, we'll call this listener. This is going to be a new server socket, and we decided that this guy was going to listen on 6881. All right, and then we'll go ahead and do our infinite loop here, and we'll say socket client is equal to listener.accept. Okay. Now, once we have a client that's connected, we want to spin up a tracker thread to retrieve that guy's IP address, and then also share the IP addresses that he's already collected with everyone else. Okay, so let's go ahead and create our tracker thread. Tracker thread.java. We'll say that this guy extends thread. Then we're going to have a private socket, the client, public tracker thread. This dot the client is equal to the client. So we'll make that connection. Let's just say initially like that. And then we need to have our public void run. Let's do a little system.out.println tracker thread started. So then in our tracker, now that we have a tracker thread, we can go ahead and say new tracker thread, passing it the client, and then telling that guy to start. We don't actually need to store this thread anywhere. We'll just let that thread die a natural death and get garbage collected. So we'll just create the instance of our thread and start. We actually didn't even need, we could have just said listener.accept in here as well for our client. We really only need that line in there. Sit here and listen. As soon as that guy turns into a connected socket, spawn or create an instance of a thread tracker or a tracker thread, and then start that thread. And then this guy will loop back around and we'll listen for the next incoming connection. All right, so that's what our tracker thread, that's what our tracker will do. Then our tracker thread is just going to spit out saying, okay, we've had a connection. Now, what else do we have in here? We have our client. So here's our client driver. So our client driver is going to need he's going to open up a socket on a certain a certain place. Now, again, our IP address or our port is 6881. 6881 is what we're going to connect to. But what's the IP address we're going to connect to? Now we go back to our picture here. In our model here, if we're writing the client software that's going to run on this guy or run on this guy or run on this guy, you know, we're writing that client software. They all initially connected to 211.21.237.3. How did they find out about that IP address? We can say that the BitTorrent protocol says, okay, it's 6881. Although the answer to my previous question is could also solve for that. So how do these three clients know that the best way to get the list of connected clients is by going to this IP address at this port? What do you think?
Maybe because that's when they first connected to, they first connected to the tracker before knowing each other. It would have the primary IP addresses.
Well, this is where they're connecting to the tracker.
Yeah.
That's what they're trying to do here. They're trying to establish a connection to the tracker, but the tracker doesn't live on their computer. The tracker lives somewhere else on the internet. So this is our client. We're writing the software that's going to run on one of these guys. How does that guy know that he needs to connect to 211.21.237.3? For any of you who've used BitTorrent before, in order to get your BitTorrent client, whether you're running like MuTorrent or something like that, to get your BitTorrent client to start, what do you first need to do? What's step one? We're going to pretend like none of the 12 of you have ever used BitTorrent. It's like, oh, we've never downloaded something questionable.
You have to type in that IP address?
Do you?
I don't know. I haven't used it, honestly. But it sounds right.
That sounds right.
That feels right. How else would you get it?
All right, let's see. Is Bushy on? He's definitely used BitTorrent.
Yeah, right. Don't call me out like that.
All right. It's possible you haven't used BitTorrent today, but you've used it in the last month.
You're just out to get me, bro.
Let's say you used it for perfectly legitimate reasons. It was a copyright free, probably something like My Little Pony fan fiction type stuff.
Yes, sir.
What is it, the bronies? But before, so if you're using MuTorrent, what do you have to download first before you can establish that connection on with MuTorrent? Don't you typically go out and download a file from some website that's a .torrent file?
Yeah, that makes sense.
All right, so you download a file from some website that's a .torrent file, that every file that you might be downloading, if you're downloading, a movie, an MP3, a software update, whatever it is, we'll just say it's completely legitimate stuff. There will be a .torrent file associated with that particular download, that particular thing you're trying to download. And in that torrent file will be information about the tracker. So that's essentially, when you download that .torrent file, you're downloading information about the tracker. Okay. So in my little example right here, since I'm running these all on the same computer for the moment, I can keep localhost in here. But we're going to put a little comment here. Replace. Actually, let's do this. We're going to create a private string tracker IP. And we're going to put localhost in there right now. And we'll go ahead and this has to be static. And then why don't we also just be complete here? We'll say private static int tracker port is equal to 6881. So we'll connect to the tracker port there as well. Okay, so these two pieces of information, below info, would have been gleaned from a .torrent file. .torrent files typically also will have the list of files that you're going to be downloading, because a lot of times you're downloading like a directory structure that isn't just a single JPEG or something. It's going to be, there might be a README, there might be a bunch of other things. Okay. But this will remind us that these things do shift. But because my computer here is acting as both the tracker and probably all the clients, which is a very poor use of BitTorrent to share a file with yourself on your own network. But tactically you can do it. So we're going to establish a socket connection. Let's see, for right now, I'm going to go ahead and just comment out this stuff below. All right, so this will open up a connection to my tracker that is currently listening on 6881. That will get that connection accepted, which will spawn off a socket, which my tracker thread expects to come in as a parameter to its constructor. And it will then set the client socket equal to that guy. And then it'll say tracker thread has been started. And we'll see that over on the server side of things. Okay, so let's just test this for right now. Let's see, I have this running in all right, so we're going to go ahead and compile our torrent. Actually, not our torrent. We're going to compile our tracker. Oh, this guy throws an exception. What do we do when something throws an exception? We ignore it. Great programming practice. All right, so now that guy compiles. All right, so we'll go ahead and get our tracker listening. We didn't do any output, so we see that it's just listening. All right, so now when we go over to our client, we have this in our client driver class. So we're going to go ahead and compile this guy. Then we'll open up a connection. The client immediately disconnected. Why? Because the tracker thread started and all he did is printed out. He started and then he immediately died, which then had our automatic garbage collection finish this client driver. So we can start it again. It'll just die again. Start it again. It'll just die again. But we'll see that 2 new threads just got created over here. Okay, so we need our tracker here to, I'm sorry, our client driver. We need this guy. So he needs to tell the tracker about his IP address. So we need to find out, how do we get an IP address given our, well, how does a running Java client find out their IP address? Let's go this route. Here's a INET4 address instead of an INET6, and this is probably going to be inside of java.net. We'll do something like a system.out.println. just gonna start typing it up here. Net 4 address. So that guy was in java.net.ip4 address. So we'll get the local host and get the host address. So this is going to be on our tracker thread. Come back out here. We'll go ahead and connect. Well, I have to compile again. We'll connect again. So this guy says, hey, my IP address is 192.168.1.136. And we see that that is my IP address right here. So that's how this Java client knows about his IP address. Now he needs to be able to send that IP address to the server. So we want this thread to receive that IP address. So we want to get the IP address of our connected client, add it to our list of peers, then broadcast the current list of peers to this connected client, as well as all previous clients. All right, so the tracker thread is going to receive that information from our client that we just proved that our client can get. Here's the client's information. And then he's going to broadcast that information to the current client that just connected, as well as all previous clients. So by our picture back here, if this guy connected to the tracker first, the tracker currently has nothing in his list of connected peers. So this guy's going to add his IP address, the 143.21. Yada, 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 to this list. All right. And then he's going to go through the rest of his list and say, oh, there's nothing to broadcast. I don't need to let this guy know about anything else. You're a single seeding value. Then when this guy connects, he's going to add his IP address to the list, this 173, yada, yada, yada. So then this tracker is going to broadcast. He's going to let this guy know about all the other previous peers, but then he's also going to broadcast to this guy about the new peer that just joined. Because from this guy's perspective, he had no peers. Now there's a brand new peer. But remember that with a tracker, we do not maintain this connection. So after this guy's talked to the tracker and gotten some information, he disconnects from there. So how does this tracker broadcast to him? This guy's going to have to set up listen for new peers. Guy a server thread. So our clients who are also acting as servers, this guy's going to sit there and he's going to have a thread that sits there and constantly listens on a certain port. You know, you can pick what port you want it to be for our tracker to reach out and let this guy know, like, hey, you were interested in this torrent. By the way, we just had a new peer. Here's his IP address for you to add to your list of IP addresses. All right, because we always want all of our clients to stay up to date. They should always know about all the connected IPs. So for Thursday, we're not going to be moving files or anything. We're going to implement the tracker and client protocols so that all peers are always aware of all, let's say, of each other. No files need to be transmitted at this point. Just proof that they get updated IPs of new peers from the tracker. Submit the get link and the self. All right, questions, what I'm asking you to do. I'll give you all this code. Added tracker stuff. All right, so that should now be up on GitHub. So that is the assignment for Thursday. On Thursday, we'll start off by going through the stuff for the final exam. And then we will go ahead and implement this and at least talk about the torrent stuff. Torrent stuff actually is not that hard once you have all these guys knowing about each other. Questions, comments, concerns, bribes? All right, I'll see everybody on Thursday.